Hi and welcome to MSc. In this video we're going to be looking at function transformations, specifically reflections. So here we have a function f at x, which is one of our standard or base or parent functions. It's a radical function. It's shown here. We're going to look at two types of reflections that we're primarily concerned about when we're talking about transformations. The first is this g at x function, which is the negative of the f at x. And what that will result in is a reflection in the x-axis. I'll sketch that out for you in a moment. The other one, which I've called h at x, it's f of negative x. And what that will result in is a reflection in the y-axis. So as I mentioned, we have our f at x function here, and it continues on like this. It's the radical function. And again, you should be probably familiar with different points along this radical function that will help you plot it quickly. It certainly helps to be familiar with standard functions as we try to do transformations to them. So let's look at this reflection in the x-axis, this g at x piece. What it will do is it will take our coordinates from our standard or original function, and it will change them or map them over to become x negative y. And this will result, as I mentioned, as a reflection in the x-axis. So all points will be reflected along this line, along the y equals 0 line. And so that point won't change. This point will change to here. So instead of it having the coordinates of 1, 1, it will now have coordinates of 1, negative 1. And so knowing that it will also go through 4, 2 will allow us to put it at 4, negative 2. And then, of course, knowing that 9, 3 will be the other point. And then we'll be able to connect these as best we can to draw our transformed function. And this is my g at x. And as I mentioned, this one up here is our f at x. Right? And we can clearly see that that's been reflected in the x-axis. So whenever we have the value out front of the function, it will reflect in the x-axis. This is most commonly what you would have seen already with parabolas, where it flips them upside down with that negative value out front. For the other piece, this h at x, here we see that the negative is inside with the x. And that will reflect in the y-axis. And what that does for us is it takes our original xy coordinates and it changes or maps them from whatever our function was originally to now be negative x, comma y. And so we can now look and say, well, this point now will actually be negative 1, comma 1. And instead of it being 2, 4, it would be instead of it being 4, 2, it'll be negative 4, 2. And then it will be negative 9, 3. And we'll have this new function that will look like this here, as best as I can lay it out. And again, it's good practice to continue beyond the axis. I didn't label these axes because we have different functions here. We'll call them collectively y, and this is my x. And so we can see that the reflection in the y-axis moves it this way, reflection in the x-axis flips it basically upside down. Let's do one last thing here, and let's look at the domain and range. So let's look at the f at x first of all. The domain is the set of x values such that x is an element of the real numbers, and there are limitations. I can't have x be a negative here. So x has to be greater than or equal to 0. And the range for the original function is the set of f values such that f is an element of the real numbers. And we also had a limitation where f would never be negative. So f was always greater than or equal to 0. So that's what we started out at. Now let's look at how this has changed with our transform functions. When we reflect on the x-axis, we'll say, okay, well, this now has a domain of x such that x is an element of the real numbers, And the condition is still, x still has to be greater than or equal to 0. Still can't have that negative and be part of the real numbers. The range, however, has changed. Here we're dealing with g. So we'll say g such that g is an element of the real numbers. And now before we had our y constraint or our function constraint being it had to be greater than 0, here now it has to be less than 0. So this has to be less than or equal to 0. And so we'll notice that the reflection in the x-axis, the value, the negative out front of the function, flips the inequality on the range. That's important to note. Let's see what happens with this reflection in the y-axis, which is really a horizontal reflection. So this, the domain here, x such that x is an element of the real numbers, where x, and now we'll say, well, x always has to be less than 0 so that the two negatives will make a positive. So this x now has to be less than or equal to 0. And the range is h such that h is an element of the real numbers, and its limitation hasn't changed from the standard or base function. It always has to be greater than or equal to 0. So we'll see this reflection in the y-axis is actually a horizontal reflection, affects the domain, the horizontal variable, whereas the out front is a reflection in the x, which is a vertical reflection, which affects the inequalities of the vertical variable. The last piece I want to show for you here is how we'd write this out now if we were to actually write it out with the radical symbol. So what we've graphed here in blue is the negative, and we put the negative in right beside the x. So it's the radical of the negative x. Whereas the g at x on this side, the g at x here, this is the negative of the root x, right? The negative's out front, it's a reflection in the x-axis. The negative's right in beside the x, it's a reflection in the y-axis. I hope this brief run-through has been helpful. If it has, consider liking and subscribing to the station. And as always, thank you so much for listening and watching.